Chapter 5b, Day 2. Learning target. I'll be able to find the complex conjugate of a complex number. I will be able to find the complex conjugate. So what does complex conjugate mean? So I copied the information from your textbook. Complex conjugate is defined as a complex number is a number of the form a plus bi, where your a and b are real numbers. So please remember, a and b are real numbers. And the I is the imaginary numbers. Do you remember that we talked it in day 1? I represent as square root of -1. That's the imaginary unit. Imaginary unit. In a complex number, z equals a plus bi. A is called the real part, and b is called the imaginary part. If b equals 0, the complex number is a real number. If a equals 0, then the complex number is purely imaginary. So what is complex conjugate? Whenever it comes to complex conjugate, all you have to do is keep the real number the same, and then you change the sign for the imaginary part. So once again, keep your real number part the same. So when I say the same, you do not change anything. You do not change sign. You do not change the value. So you just repeat the real number part. For the imaginary, if it were given positive imaginary numbers, then you change to negative imaginary to get to the complex conjugate. If you were given negative imaginary numbers, then you change it to positive to get to its complex conjugate. So complex conjugate, it's almost like the companions with each other. So take a look at the examples. Give the complex conjugate of each. So example number 1, we have 1 minus 3i. So notice I said, keep the real number the same. So 1 is a real number. I'm going to keep it as 1. And then I change the negative 3i. So negative 3 is the imaginary part. So negative 3 turns into positive 3i. So the complex conjugate of 1 minus 3i is 1 plus 3i. Is this simple enough? I think this would be the simplest homework you're going to work on today. Number 2, 4 plus 2i. What's the complex conjugate? Again, keep the real number the same. So 4 stays the same. 2i turns into negative 2i. So the complex conjugate to 4 plus 2i would be 4 minus 2i. Number 3, negative 1 minus I. So please, whenever it's negative number, it doesn't really matter for real numbers. So just repeat it. So negative 1 stays as negative 1. And then for the imaginary part, negative I, you have to change that into positive I. Number 4. This is just a pure imaginary number, I. So what's the complex conjugate? Since there's no real number, 0. We can change the imaginary into negative I. And that's it. Complex conjugate. Keep your real number the same. Change the sign for your imaginary part. Next, we're going to extend that information to simplify rational expressions with complex numbers. Rational expressions means that it looks like a fraction. A fraction, so you'll see a big bar in between. How do I rationalize? How do I simplify rational expressions with complex numbers? So I'm just going to tell you straight. Multiply the complex conjugate of your denominators, top and bottom. Multiply complex conjugate of your denominator, top and bottom. So take a look at example number 5. I have 2 minus 6i over I. This is a rational expressions with complex numbers. So what do I do to simplify it? So again, simplify means you're going to get rid of the imaginary numbers at the denominators. So what's the easiest way? multiply your top and bottom with the complex conjugate of your denominators. So what's the complex conjugate of I? So I is the imaginary unit. So multiply top and bottom with negative I. Negative I top and bottom. So I times negative I have negative I squared at the denominator. Negative I squared is negative 1. So minus negative 1 becomes positive 1. And then for your top, you just use the FOILs. So I is treated like a variable, FOILs. Okay, so go ahead and multiply. 2 times negative I have negative 2I. Negative 6I times I have 6I squares. So 6I squared, again, I can use 6I squared as I squared is negative 1. So this is basically turning into negative 6. Negative 2I stays the same. And then when it's dividing by 1, it's just the same number itself. So negative 6 minus 2I for number 5. Number 6, 3 minus 2I divided by 1 plus I. So again, how do I simplify it? I am going to multiply top and bottom with the complex conjugate of the denominators. What's the complex conjugate of 1 plus I? It's going to be 1 minus I. So I have to multiply top and bottom with 1 minus I. So here you will have to do FOILs. 1 plus I times 1 minus I at the denominators. It's going to be 1 minus I squared. So for denominator, it's going to be 1 minus I squared. Make sure you carry out the FOILs if you're still struggling with this concept. First, outer, inner, last. How about your top? For the top, I have 3 times I, so that's 3. 3 times negative I, that's negative 3I. Negative 2I times 1, that's negative 2I. Negative 2I times negative I, that's positive 2I squares. And then we're going to simplify. Don't forget, I squared is negative 1. So that the denominators, 1 minus negative 1 become positive 2. 3, where did I get the minus 2 from? Minus 2 is from this number, 2 times negative 1. I squared equals negative 1. So 3 minus 2. And then combine the like terms, you combine the imaginary part. Negative 3I minus 2I, which is negative 5I. 3 minus 2, I have 1. Negative 5I. The whole thing divided by 2. That's the simplest form. Number 7. What's the complex conjugate of your denominators? 5 minus I. So again, keep the real number the same and then change the sign for your imaginary number. So the complex conjugate for your denominator is 5 plus I. Multiply that to your top and bottom. So now you will have to carry out the FOILs. So again, treat the I just like the variable x. So FOILs, when you see, it's like going to be the binomial times binomials. 5 times I, we have 25. 5 times positive I, that's 5I. Negative I times 5, that's negative 5I. So 5I minus 5I, no more I. Negative I times negative positive I have minus I squares. For the top, do the same thing, use your FOILs. 2 times 5, that's 10. 2 times I, which is 2I. 5 times 5, 5I times 5, that's 25I. 5I times I, that's 5I squares. And then from here, we simplify. I squared, don't forget, I squared is negative 1. So at your denominator, you have 25 minus negative 1, which is 26. 5I squared, again, at your numerator, 5I squared is negative 1, so that becomes minus 5. 10 minus 5, which is 5. 2I plus 25I, I have 27I. So the final result is 5 plus 27I over 26. So make sure you practice the multiplication of complex numbers as in the form of like binomial times binomials. Treat the I just like an x. Distribute or follow the FOIL method that you are very used to.